last lecture, we designed a circuit in freezing, and this is how it looks like. So I call this the hello world circuit. It's the simplest circuit that we are doing. And this circuit has LED, and then we just want to light it up or maybe blink in the LED. And then here's a resistor. It's for protection of the circuit. And the positive comes out of the GPIO pin 18. We're using that as the pin that we're going to send a signal to LED to turn it on and off. And then the negative goes to the ground, and this pin here is a ground. Okay. So first, let's actually build this physical circuit with a pi, and then we're going to create a program to blink the LED. Okay, let me switch to the other camera. All right. So this is the pi that we have assembled so far. Comes with this white case for Canon kit, and right now is actually the right time to actually add this fan in here, and because we're going to be running some programs on the pi, and the pi is going to get a little warm. The fan just helps with cooling it down. So it's a good idea to actually have the fan in here. Now, I have shown you how this fan might be connected on this the GPIO pins on the board. So let me just kind of explain this first. The fan has two cables. One is red, the other one is black. So the red typically represents a live wire, and the black typically represents ground. So this is not what you're going to do, but I'm just going to explain this first, and then we'll do it in a different way. So we want to connect this fan to this 3.3 volt port. Now the 3.3 volt, if you recall, is the very first pin, the physical pin number 1. You can go back to that pin out to see, well, remember you have the Canon kit reference, the GPIO reference card. You can look at that, or let me show you a different way. You can go to this pinout.xyz. So it's over here as well. So you see this physical pin number 1. So the numbers in the middle, these are the physical pin numbers. So 1, 2, 3, 4, and all the way until 40. But when we program with the libraries, we typically use the GPIO pin numbering, like this GPIO 2, 3, 4. There's no particular, it's hard to remember, actually. You just have to look at the reference card. And all this pin out on this website if you don't have the card. And this is a ground pin. Now there's a in total 8 ground pins. So we're gonna just use this one. This is the topmost ground pin. All right, so back to that fan that I was showing you. So if you were to connect the fan to the GPIO pins on the board, on the pi directly, and then you would just, the red goes to the physical pin number 1, 3.3 volt, and the black pin goes to one of the ground pins. So in this case, I connected this physical pin number 246. Okay, so that's a ground pin. And in this, you can run this normally if you're not really using the GPIO header. But then we are going to be using the GPIO header, so we're not doing it this way. We're going to actually, first thing you want to do is, so I'm not going to take this off. I have another Pi with this cable connected. So let me show you. This is the extension cable, the GPIO extension cable. We want to bring that GPIO pins out to a breadboard. So you position your Pi this way. Okay, so the physical pin number 1 is on the right-hand side, and in this way, in the horizontal row format. And then you take out this cable. You'll notice one side is marked red. Okay, there's a red cable on the rightmost side. So you position your cable like this, and then one end of the cable, you're going to install this onto the Pi, the GPIO header, like this way. Okay, so when you do that, and you would want to take out the middle portion of the case, just makes it easier to work with. And make sure you take out the power cord. Okay, no power when you're making changes to the physical circuit or doing anything with the GPIO. Do not connect the power while you're working on this, otherwise you may damage your Pi. So you may want to take out the middle portion of the case while you're putting that cable on, right? So when you put a cable on, just really aim the pins with the holes properly. Make sure it's even on both sides, and then gently push that down. If you cannot push that down, like if they're uneven on two sides, then you may have to redo it. Just take it out and redo it. Okay, just gently push that down and push it down all the way. Okay, not halfway, just all the way down. Okay, every pin goes to every corresponding hole on the cable. So once you get that installed, then put it back in the middle piece of the case. All right, now you're going to install the fan. Take out the fan is in one of those packets. And when you push the fan into the top cover of the case, so let me show you. So you position the top cover this way, right? This is the GPIO pins this way at the bottom. And your USB ports on the left-hand side. And the top cover, when it goes on, the Raspberry Pi is this direction, the Pi logo, right? The leaves at the left-hand side, or the words of a Kanaka is on the left. So when you position this way, when you need to push in the fan to the slot on the cover piece, and the label, you see the Kanaka is facing you. You see the label. So the other side where it doesn't have anything, you push that into the square. Now, then there's two cables coming out of the fan for connecting to electricity. And you put that, position that cable to the top right corner when you flip it over like this, all right? Okay. So when you do that, and let me actually take these cables out. So then when you close the top piece, now you can close it now, okay? When you close it, make sure the fan cable is coming out of the right-hand side at that corner, this little gap right here. And then your GPIO extension cord comes out of this side. Just this is where the GPIO pins are. You just connected the one side of the cable, right? The extension cable. So they will hang out of this gap right here. So if you close the top and make sure the right fan cable is coming out the right side, and then you push this on. So you see this is the fan cables, and then you imagine your GPIO extension cable coming out of here. Okay, there's a gap that's designed for this cable to come out. Okay, so once you have that, now next thing you want to do is connect the GPIO extension cable to the GPIO extension board, which is a T-shaped board like this. Okay, see this? There's a pins that you will put onto the breadboard. But first thing is to connect the cable to the extension board header. Okay, so on the top you have those pins coming out, and then just push this the other side of the cable onto the extension board, and same drill as the other side where you put onto the Pi board. And so you put this onto this extension board here. Once that is installed, and then you need to put this push this extension board onto the breadboard. So just align the pins, right? It's the 40 pins. Align the pins that are to the very first line of the breadboard, very first line of the holes, right? And start from there as the first, basically the physical pin number 1, 3.3 volt, goes on to the first row. And I also position this 2 columns of pins right in the middle, okay? So the middle gap that marks the middle point, the middle line of the breadboard is in the middle of this extension board. So essentially, this will go on to the left side, it goes on to the second column of holes. So, and then the right hand side also occupies 2 holes, right? So the both sides will occupy 2 holes. So it'd be like this. Okay. So you got that, and now get this installed. And now you want to install the well, the next thing we install actually is let's do this. Take out one of the shortest jumper cable that you got from the kit. It's on the shortest piece. So like, for example, like this piece right here, or the yellow one, or the orange one, whatever, small one. And then push that basically from, you see on the right side of the pins, the right column here, the third one, this is the physical pin numbers 2, 4, 6, the physical pin number 6, right? If you remember the physical pin numbering, this pin is written as ground, GND for ground. So you connect that jumper cable. The one side goes to the breadboard column that's marked with a negative sign, right? And that negative sign column is going to be our ground column. So one leg of the jumper cable goes to this column, the very first hole of the negative column, and then the left leg connects to one of the holes on this ground column. Okay, sorry, ground row. There's 3 holes left because the extension board occupies 2, covers 2, right? So there's 3 holes left. Just push that into one of those holes. They're all connected. And remember, I've shown you an image of what it looks like without the plastic. So every row is connected with a metal, and then the positive and negative, those are columns connected each with a 1 column of metal. Those are connected vertically, and then each rows of 5 holes that are connected horizontally, right? So by connecting that hole out to the column, the negative column. Now we have a whole column of ground that we can use now. So we're not going to need to use any other ground that's marked on the extension board anymore. Okay. Okay, now let's connect the fan cables. So bring out 2 of the longest jumper cables out and use a, now you can use your hand, but if you actually have a needle nose pliers, you want to, this is convenient, and you may use this for various different purposes while you're working on a physical circuit. If you don't have it, just, probably you can just use your hand to bend that. Well, you want to straighten out, just take out one of those long cables, and because they are bent 90 degrees, so you just basically, just straighten out the ends, okay, with the pliers or whatever, or with the fingers, and to make that straight, and then just connect that. Yeah, get 2 of those and then push this into the female end of this fan cables. Okay, push this inside all the way down. It'll be pretty snugly. Okay, and then the other end. Now remember, there's 2 cables here. There's a red and there's a black, right? So connect the red. Connect the red. Now what I've shown here to one of those holes from the physical pin number 1, 3.3 volts, right? Just push it into any one of those holes. And then the black one, the one with the jumper cable, which may not be black, but I have a black one here to show you. And push that down into the one of the ground holes on the right. Remember, we have extended the ground to the column now, this negative column. So you can basically just push this fan ground cable, which is black, into into the very first, will be the second hole from from the top, right? Just push it in there. Now you got your fan connected. Okay. Now let's build a circuit. Now, first thing we want to do is we always, it's kind of convenient, or maybe it's probably a good idea to start from the pin from the GPIO. So remember, that's where the current flows. The current flows from that GPIO 18. We're going to connect to that pin number 18, GPIO 18, right? So there's 3 remaining holes on that row. They're all connected with a metal underneath. So you want to bring another jumper cable out, and one end goes to one of those holes that's from the row of GPIO 18. And the other end goes into wherever you feel like, okay, in that blank space on the breadboard. Okay, so just bring it down, beyond the extension board, so you have more space to work with. You don't want to be cramped in that one place. In fact, you will not have enough space to put in other things. Just do that, okay? Bring it down, like what I did here. Next thing you want to connect, if you follow that diagram, you're freezing, okay? Next one we want to connect is the LED. Okay, let me explain the LED. And go ahead and take out an LED. I have a red color here. You can use other colors if you want. It doesn't matter. So this is the single color LED. Let me show you. This is probably the one that you've got. So notice that one of the leg is longer than the other. Okay, one is longer than the other. This is how they're designed. Okay, now the LED is polarized, meaning it has a positive and negative terminals. The positive terminal is actually called the anode. The negative terminal is called the cathode. So there are the general terms for those anode and cathode is called electrode. These two things are called electrodes. The two pieces of metal coming out is electrodes, so it's more accurate name for electronic components. The longer leg is called an anode, where is the positive end of it. So the current flows current flows from the anode through the LED and comes out of the cathode. So when you put this onto the circuit and you want to take the anode, which is a longer leg, into the row, one of the holes from the row where the jumper cable that extends out the gpio 18 is where the current flows. And then that lands on one of the rows, right? So make sure the longer leg, which is the anode, is connected to one of those holes on that same row. And then the cathode, the shorter leg, put that into the next row, okay? Maybe the row below. Okay, it's narrow enough, you can only really use 2 rows on the board, okay? So once you have that, push it in. Now we got the LED installed in the circuit. The next component we want to do is the resistor. Now, the resistors look like these, right? So you've got a bunch of resistors, and in fact, I don't know if yours come with markers of the values of resistors. The one we want to take is a 220 ohm. That's the resistance value. 220 ohm, and then it will actually mark which piece, which one is the 220 volts, 220 ohms. So just take one of those out. Now I need to explain how to read the. Now this is a mark now, but now once you get those things loosed out into your box, and then in the future, how do you recognize which is which? You don't need to label them because they come with labels. The label is in the form of the color bands. So this is a card from the Canna kit. So take that out now. So there are 2 kinds of color bands for resistors. There's a 4-band code. There's a 4-band resistor. There's a 5-band resistor. Just count how many bands of a color are there on the resistor. The one you got from the kit, it's probably 4 bands, okay? So if it's a 4 bands, first of all, you need to position this like which is left, which is right, right? When we read the bands, there's a particular order, it's a sequence. The trick here is first identify the widest color band. Check which band is the widest. The widest band is on the left. That's the rule. Put the widest band on the left. This is how you're gonna read. Okay, the widest band may be the first band or the second band, typically. Okay. Now we're gonna start reading from the leftmost band. Once you position it properly, the leftmost band is the first band. Now look at the color. So for the 220 ohms, the first color will be red. Okay. If it's red, you get a number 2. And the second band is also red, and you get another number 2. And the third band is called the multiplier. So the third band in this case would be brown. And then the brown gives you a multiplier of 10. So essentially you have 22 times 10. That gives you 220 ohms. And then the last band on the right is the tolerance level. It's basically the variance of the resistance value when it's being used, depending on the temperature and the other factors, or the resistance value might fluctuate a little bit. So a high quality resistor may have very low tolerance, like plus minus 1%, but then the lower quality resistors may have a high tolerance value. That means the the actual resistance may be plus or minus 5% of the value that we just figured out with the other three bands. So normally you don't really have to worry about that much. In the case of our circuits, we don't need that kind of accuracy, so it doesn't really matter. Okay, so the one that you got from the kit, maybe that tolerance is brown, plus minus 1%, or maybe it's gold plus minus 5%. Okay, so that's how you read the color bands on a resistor. Now, if you have 5 bands, the only difference is that the third band is also a number. So the third band is one of those colors, and then you're going to figure out, okay, now you have 3 digits instead of 2 from a 4 band. So you have 3 digits that gives you a range from 0 to 999, and then you multiply with the multiplier. That's the 4th band now, so or the second to the rightmost band. And the last band is always the tolerance. Okay, that's the kind of little difference between 4 band and the 5 band resistors. Okay. So now take out that one of those 220 ohm resistor. The one of the leg is a very long legs, so there's no polarity, so either side is fine. There's no, so it's okay. So just take one of the legs, put that into the row of the cathode of LED. Remember, that's the next row, the row below, because the current continues. Imagining the current flowing through the LED. Now it's going to flow through the resistor, and the other side of the resistor, the other terminal of the resistor goes into the negative column. Okay, these are the ground, remember? So all these holes can be used as ground, this whole column. So once you push that in, then our circuit is complete. Okay, now let's test it with a little program. Well, plug in the power for the Pi, and we're going to test the circuit. Now back to my screen. So open up a VS Code program on your computer, and then we're going to establish a SSH session to the Pi. So remember what I showed you initially, how to use a VS Code. So click on the bottom left corner. There's this green button here. Click on that, and then choose the option Connect to Host. We have this Pi host name remembered. I have a different Pi here on this computer. So RP4, you may have the RP2021, that is the name I suggested. That's maybe what you have. Just click on that. Okay, so just make this a little bigger. Now you notice at the bottom left corner, it will say SSH : the host name. So we have a remote session connected to the Pi now. Okay, now we need a place to put the code before we can run it. And we'll have this terminal here automatically open. This terminal is already logged into the Pi, and this is on SSH session. And we can issue commands that will run on the Pi. Okay, so first, this is why in the current Pi user's home, remember last time we probably created a dev folder. If you, that's just my own convention where I want to put my code into the dev folder. And I may have some other folders there already, but I'm going to create a new one for this course. I just call it CIS-30D, okay? So this is where I'm going to put the code for this project. So here in the Explorer, I want to open that folder. Click on Open Folder and type in dev. And if we type in slash, it will show you the current folders under that dev. And so this is the one we just created, CIS-30D. Click on that, and it will say OK. Okay, so now we're in this folder, which is empty now. So we're going to create a new file called hello.py. Okay. We're going to use a library called gpio 0 to control our LED. And okay, here I got a prompt saying the Python interpreter is not selected. I'm going to select it. And I pick the one that says 3.7.3 and in the folder user bin Python 3. So this is the one that comes default. I may have other things installed there, but don't mind, you want to use the one as the default, and Python 3 as well, not Python 2. That we don't use Python 2 anymore, just use 3. So pick that one. And in fact, the Python version will be displayed right here. So Python 3.7, 32-bit. So remember the Raspberry Pi OS is a 32-bit OS. Well, they are working on the 64-bit, by the way, until that comes out. Right now, it's 32-bit. Okay. And it's not going to make a difference for the purpose of this course. So just that's what we're using here. Now, first, I'm going to import a LED class from that gpio 0 library. And I will say import LED. Okay. And then I'm going to save this line. And then there is it shows a squiggly lines like error here because there's this program called Pylance. Pylance is checking, well, the conventions and trying to be helpful with types and just provide, intelligent assistance for the IDE. So it's a plugin for that purpose. And we want to make this happy so that, it's going to help us when we type in the code, it will prompt and show us the options, and it's typically very useful. So I like to fix this. You don't have to. I mean, it's it's not that the program is invalid, but this is for the purpose of Pylance, which will make your Python programming a little easier. So I'll click on this quick fix. It gives an option to say create type stub for gpio 0. Now I say click on this also. So it will generate a folder called typings with a bunch of files in there. You don't have to look at the details of what they are. Just let it sit there, it will be fine. And then the LED here shows an error here because it's not being used. When importing a class, it's not being used. So you see, it's trying to enforce some good conventions and to help you tidy up your program. So of course, it's going to show that as an error because we're not using it yet. So let's use it right now. Let's create an LED object. And let's see, as soon as I type the parentheses, it's going to show me the parameters we can put in there. So in fact, the only thing I would care about at this point is the pin number. So this is the GPio pin number 18. Okay, this is what our physical circuit is connected to, and this is also from the very beginning we designed this with freezing, so it's all the same value. So we're using pin 18. That's a GPio pin 18, not the physical pin number. When we program, Primarily, we're going to use a GPIO pin number. So now we have an LED object, and then we can, you know, let's see if as soon as I type dot, it's going to show me all the attributes of this object. So the one that we're going to use is blink. So I want to blink that LED, and there's a bunch of options here for the parameters, and I want to say I want to keep the LED on for 1 second. The second one is now we're going to say after 1 second on, we're going to have 1 second off. And then the third parameter here is saying how many times do you want to this blink. The blink sequence is on, off, there's a blink, right? So on 1 second, off 1 second. Now we're going to do this 10 times. Okay. So we have this program now. We can actually run this. So let me switch to the camera and pay attention to the LED. So I will just click on run. Now, remember how you run this thing. So it's very convenient with the VS Code. And so you see the top right corner, there is a green button, a triangle, green triangle button. You just click on that, it will run it. So I'll click on this. Have you noticed what happened? I think it blinked once, right? Let me try one more time. See, it just quickly blinked once and then some disappeared. So it's not really doing what we wanted. We thought it was gonna, you know, turn on for 1 second, turn off 1 second, and then do that 10 times. It was not doing that. So it turns out there's an issue with the code. Let's go back to the code. And the issue is there's another parameter. Take a look at the last one, it's called the background. And look at the explanation of background. So if true, which is the default, it will start a background thread to continue blinking and return immediately. Well, because it returned immediately, our program basically ended. And it will not show, it essentially just, you know, blinked quickly, like turn on for, you know, kind of a couple of milliseconds and then it's done. The program finished. And we didn't want that, okay? We wanted this thing to run until finished. So we don't want to put this in the background, and then which is the default. So I'm gonna just pass in this false value here. Okay, so that it will blink 10 times and then it will finish. Okay, so let me switch to the camera. And then I'm gonna run this. Okay, see on 1 second, off 1 second, it keeps doing that. It's gonna do that for 10 times. So now it's doing that properly. So I'll let this finish. All right, it's done. So that's it. And before you disassemble the components on the board, make sure you power off the Pi. Either you take out the power cable or you use this on-off switch. If you connect the on-off switch to the Pi, the one that comes with the Canon kit, then you can just, you know, press that button on the switch, either way. So before you change your physical circuit, always remember to power off. Okay, so that's pretty much it. Thank you.